So this is another example that I like to show you. As you can see here, we also have a lot of block references that represent the elevation spots of a terrain. In fact, I just copied them over from another site plan. When you look at these block references from a side view, you can see that they are slightly different than the ones we had in the other drawing. As you can see, none of these block references has a Z position, so the Z position is 0 for all of them, which means that they are lying really flat on the ground plane. I will switch back to the top view and will examine one of these block references a little bit closer. But you can see that in fact they have a C value, but the C value is stored as an attribute inside of the block. I will double click this block, which will bring up the attribute editor. You can see that the Z value is written inside this attribute. If you want to create a triangulated model from this, what we have to do is to push all these blocks to their correct position in space. To do this, I will use quite a similar technique that I used in the other video. The idea will be that I will extract the X and Y value from the block and the C value from the attribute that is stored to the block. To do this, I will bring again up the Autocad data extraction tool. So I enter data extraction in the command line and I will create a new data extraction. Press the next button and I will save it on my desktop and call it coordinates. Press the save button. Here we'll check the select objects in current drawing and just select the block references that I isolated. Click the next button. Here I will uncheck again the display all object types because you can see that he's displaying some non-block objects that I'm not interested in. So I will uncheck this and he's displaying only the blocks. Press the next button. On the next page I will uncheck the MISC, the general, the drawing and the 3D visualization category. It's displaying me now only the attribute and the geometry properties. From the geometry properties I will uncheck the scale values. Also I will uncheck the position Z because it will definitely be 0 for all of the blocks. And press the next button. On the next page I will again uncheck the combine identical rows to make sure that AutoCAD treats all of these blocks as individual objects. Next I will hide the count column and the name column. I will take the quota column, move it to the end and rename it to position Z. I press the full preview and quickly check this. It looks good to me, so I cannot see any 0 values, which will definitely cause problems for the triangulation. I press the next button. Here we'll check the insert data extraction table into drawing and the output data to external file. I will save it again as a text file. I will call this text file coordinates also. Press the next button. The table style options I all leave on default because I will just use this table to make sure that he took into account all of the blocks. Press the next button and finish the extraction. He will give me again a warning that the table will be quite large. Anyway, I will insert it into my drawing. So you can see we have 686 blocks. So this table should have at least 688 rows. And it has these 688. I don't need this table anymore, so I will just delete it. Also, I will quickly check the text file that Autocad created, which looks quite good to me. I will leave it how it is. What I will do next is to draw a really simple elevation spot with an attribute, and with this new elevation spot I will replace the old elevation spots. In a sense, I will use a script that will help me to copy this new elevation spot to exactly the same position that I extracted into the text file. I will just draw this elevation spot. I will use the standard AutoCAD tools. So first I will draw a circle, something like this. Then I will draw a polyline, probably like this. I will mirror it, and then I will rotate it as a copy about 90 degrees. I will create a new layer. I will call this layer elevation spots. Give it a bright color. Also, I will make this layer current. Then I move these lines to this new layer also. Next, I will create a simple attribute that will reflect the C value of the elevation spots. To do this, I enter add_def in the command line. This will bring up the attribute definition editor. Here I will uncheck the log position because probably I want to move them around. Don't know. As a tag, I will enter elevation spot. As prompt, I just enter C, and as default value, enter C also. This I leave how it is. This is okay. Just I will lower the text height a little, probably to 0.6 or something. Press OK, and I will put this attribute really close to the mark. Next, I will create a block from these. So I enter block in the command line. I will call this block elevation spot. Press OK. It tells me that I have no object selected for the block, so I select both the attribute and the lines that I drew. Press the Enter key. OK again. As an insertion base point, I take the midpoint of the circle. Leave everything how it is, press OK. Take the block, right click, and open it in the block editor. Here I will double click the attribute. In the default line I will enter a field. I switch to the placeholder, block placeholder category. In the block reference property I switch to position. I will uncheck the X and Y position because I'm not interested in. If you want to display it, of course you can do it. But in this case I only want to display the C value of the block. I lower the precision a little bit, which should be good enough. Press OK. OK. Enter. Close the block editor and save all the changes. Next, I will use this this nice little script called ASC point. So I enter ASC point in the command line. He will bring up a dialog asking to import coordinate data. I will switch to this text file that I created. What the script will do, it will take the block that I drew and will copy it to exactly the same coordinates that I extracted to the text file. So I choose the coordinates text file, press enter. Here I choose inserts. I select the block that I drew. And now we just have to wait a little bit of time till he's finishing the job. So as you can see, he finished the work and he copied the block to the same coordinates specified in the text file. I will switch to a side view. And you can see that now these elevation spots have the correct position in space. Now I will switch back to my top view. My computer is a little bit slow because of the screen capture software that is running in the background. But I hope he will do this. Yes, this looks good. This is the block we used as a reference. This I will delete. I choose the new blocks that he created and isolate them. Now I can use again the script that I used before, the digital terrain model script. So I enter DTM in the command line. He's asking me to select objects. I select them all. Just wait. And he created the model for me. I will switch my viewport now to the 3D Basic. Change the view from 2D wireframe to something like shaded wireframe. And switch to kind of isometric view to have a better look at the model. So this model is ready to be exported and ready to be populated with, don't know, with trees, streets, or just what you want to do with it.